Today we're going to be doing something a little bit special. This map right here was designed by my 10-year-old son Arthur. He made it just for the game we're going to be developing today. And here's what it looks like when we bring this drawing to life inside of Unity. In this video, we're going to clean up this hand-drawn map inside of Photoshop. We're then going to import it into Unity and use it as the basis for our UI map in our version of Five Nights at Freddy's. We're going to make it slide in and out using mouse hovering, and we're going to set up clickable buttons on the interface so that we can move to different rooms that cameras are within. This is part 2 in our series in building a Five Nights at Freddy's 2D game. By the end of this video, you'll have all the tools necessary for you to expand and add your own custom rooms. Let's start by how we're going to prep this hand-drawn picture that my son made. I'm going to be using Photoshop because I'm most comfortable with it. There are many alternatives out there, and so long as you can crop, rotate, paint, or manipulate the image in some basic ways, it'll be fine. Go ahead and scan or photograph your picture. If you're going to photograph it though, please try to get it as flat as possible and take it straight on with even lighting. It just makes it a lot easier to edit later on. You can use a tool like crop or your ruler inside of Photoshop to realign, resize, and reorient the image. You might want to consider editing the levels on your image, especially if you don't have a lot of good contrast. Editing the levels will allow it to pop more and might isolate individual room outlines. In Photoshop, you can use the Ctrl-L hotkey when you have a layer selected to adjust the levels. Now my son decided to add a ton of extra information, and this makes the map pretty busy to work with. I went through and reworked the entire outline of the different rooms, trying to stay as true as possible to his original design. In Unity, we'll be adding all the boxes for the cameras using UI elements, so don't worry about capturing that yet. For now, just trace the various outlines of the different locations inside of Photoshop or whatever program you're using. I went ahead and created a new layer and then selected different regions using the rectangle tool, and then I would fill them in as I'd add different rooms and connecting branches. In order to add an outline to the entire layout, I used the layer property stroke and then chose a light gray color. In retrospect, if I had to do this again, I would probably use the grid and snapping to make sure that the rooms were a little bit more evenly sized and the hallways stayed consistent. Now this is optional, but you might want to export this with transparency, in which case you want to select all the regions outside the image that you don't want to be part of the export, and make sure you delete them. For my image, I ended up resizing it to a power of 2, specifically 4096 by 2048. Now we're going to add that map into our user interface inside of Unity. We're going to make the map a UI element, then we're going to add a little arrow at the bottom, similar to what's in Five Nights at Freddy's, the first one. When you mouse over it, the map will pop up. When you take the mouse away, it will disappear. I went ahead in Photoshop and I created a UI element, a little button for us to use at the bottom. Go ahead and drag and drop the ping file into your project directory. I put mine in a folder called Map. That's where I'll be putting all of our map assets we're creating today. Go ahead and click on the image in order to see it in the inspector. Make sure it's set to Sprite 2D and UI, not a default texture object. If you're working from our prior project, you already have a canvas in the scene with a background. However, if you're starting fresh, go ahead and create a canvas object. Inside that canvas object, right-click and add a new image UI element. Rename this map or map panel, something like that. Go ahead and assign that sprite you just drag and dropped in, the map you created, to that image. Now I'm going to anchor this image to the bottom of the screen just to get its position centered where it should actually be. I'm also going to make sure that I respect the aspect ratio of that image and then resize and tweak it until it looks good. I'm then going to move the entire map off of that anchored position and off to the side, similar to what Five Nights at Freddy's has. This is going to be our default location where the map will rise up to. So make sure you put it wherever you want it to eventually be. Now we're going to concentrate on adding the visible arrow at the bottom that's going to be used when we mouse over it to bring the map up and down on the interface. We're going to control map visibility with this image at the bottom of the screen. I went ahead and created something similar to what's in Five Nights at Freddy's and dragged and dropped it into my project. We need to do this actually in 2 different parts. The reason is because how Unity handles events. First, we're going to create the top level, which is invisible. It's going to be sensing when the mouse enters that region and exits it. we're going to have a child object actually display the visual arrow itself. The reason is because if we turn the arrow on and off, that region can also disappear. By having these things separate, we can control the visibility while still monitoring when the mouse enters or leaves that area. Go ahead and right-click in your canvas, choose UI and Image, and then go ahead and assign that arrow sprite to that image. Take a few moments, realign it, anchor it to the bottom, and get it somewhere that's convenient for you. I chose in the center, kind of wide set, just like in Five Nights at Freddy's. I'm going to rename this map trigger. Now we can speed things up a little bit by duplicating this object. So go ahead and hit Control D with it selected in your hierarchy. Rename it to visual arrow and drag and drop it to be a child of the map. Go ahead and set the image of the map trigger, the parent of this visual arrow, to be nothing. Now it appears like nothing has changed, but what we've done is set up a hierarchy where we have a parent, that's going to be the hover area, and then we have a child, which is the actual visual. The parent will always be present and always be monitoring for when the mouse enters and exits, and the child will be turned on and off, indicating whether or not it's available to select. For our next step, we're going to be setting up the event triggers that are going to allow our map to actually function when we mouse over the arrow. To detect when the player enters this region, I'm going to be using an event trigger component on the map trigger. Go ahead and add the following two events to the event trigger. The first is a pointer enter, and the second is a pointer exit. We don't have functions yet to call, so leave them blank. We'll get back to that in the future. Now we need to create our script. So if you're not a programmer, you can head over to my website at gleecakes.com and find the entire script written down for you that you can copy and paste into the editor. If you are a coder though, I'm going to walk through this and generally explain it on a high level how everything works. Go ahead, right click in your map directory in the project and create a new script. Call this script Map Animator. Go ahead and drag that script onto the map panel. The map animator has several different variables we expose that are public that we can drag and drop into the inspector. The first is our rect transform. This is going to allow us to manipulate the position of the map and move it up and down on the screen. Next up is a reference to our image, that is the arrow at the bottom. This is going to let us turn that image on and off so that as we mouse over it, it disappears. Then we have the speed of the interface, how quickly it's going to move up and down. We then have two vector 2s. These are going to store for us the location where the map should be when it's visible and where it should be when it's off the screen. Finally is an audio source. We're going to add an audio source to this object so that when we mouse over and we expand the map, we get a nice clicking sound similar to what the game actually has. Our start method fires when the game begins. We're going to make sure we record the position of where the UI element is and store that within our visible position parameter. We're then going to move the map off the screen by moving it to the hidden position location. We now have 5 methods I want to briefly talk about. The first is on arrow enter. This is the one we're going to hook up into our trigger when the mouse goes over it. This is going to check to see whether or not the map is visible, and if it's not, it's going to try to show it. And if it is, well, it's going to try to hide it. Then we have on arrow exit. It's just going to set some of our variables to make sure that we know the arrow is no longer hovering over it. Then we have show map. This is going to be responsible for stopping and starting all coroutines going on. The idea is the user could move their mouse off and back on again while the map is still coming on or off the screen. We're going to be using a coroutine to handle slowly moving the map back up into position and returning it. So we want to stop whatever coroutine is currently going on and then start a new one. And that's going to be slide 2. Hide map. This is going to, of course, stop all the coroutines again and then move the map off into the hidden position location using the same slide 2 coroutine. And finally, the most important method we have is our enumerator method called slide 2. This takes a vector 2 object in, that is whatever position you want the map to be at. This is going to use a lerp function to smoothly interpolate between the current location and its final destination. Now we're going to go back and hook up our event triggers to the functions we just created. So under our map trigger, we're going to go ahead and under our pointer enter, you're going to drag and drop whatever object has your map animator script attached to it. Now the drop down on the right side will come alive. You'll be able to click on that, go into map animator and choose on arrow enter. You're going to do the same thing for pointer exit. You're going to drag whatever object has your map animator component on it. And then you're going to select the on arrow exit function. If you coded everything correctly or copy and pasted it right, now whenever you mouse over that, it should fire off that coroutine and make the map return to the screen or disappear. The final thing we need to do is add our sound effect. We had an audio source reference that we added to that script. Choose whatever sound effect you want to. I happen to create this click sound using Adobe Audition. Select your map and then add an audio source and drag and drop whatever sound effect you want onto it. Now drag your map onto the audio source component that's now exposed in your inspector in your script. If you try and run your project now, you'll end up with an unassigned reference exception. We need to connect the references in our map animator script to the map panel's rect transform and the arrow image component. Remember, during the start method in our script, we move the map panel off the screen. We are acting on a null object if we don't assign a reference, and it'll throw an error. You'll also need to set the hidden position of your map. I went ahead and took the X value from the rect transform of the map and used a negative Y value, around negative 360 pixels, to move it below the bottom of the screen. Now let's test things. Hit the play button in the top center of your screen. Now when I hover at the bottom of the screen over the arrow, you'll notice the map slide up into position and the arrow will disappear. Once we move the mouse off of the arrow will reappear, allowing us to then move back over it and cause the map to slide back off the screen. Now let's turn our map into a working camera controller system. But instead of using basic buttons from the Unity UI, which have a lot of functionality we don't need, each camera control is going to have 3 different parts. The first is a background that we can change the color of based upon whether the camera is active or not. Then we have a border graphic. This is kind of optional, but if you want to spruce up the look, you can use it. And then finally is our text label. We do the text label inside of Unity so it can be dynamic, and we can change the camera names to be anything we want. This is going to let us do things like the original Five Nights at Freddy's game has, those blinking backgrounds that go from gray to green as a camera is selected. Let's start with building the clickable camera areas. We're going to start by creating one and then duplicate it multiple times to add as many cameras as you'd like. The first object we're going to create is going to be called cam_storage closet. Right click on your map and add a new image object. This is a dummy placeholder object. You're going to remove the image from it. You don't want that. You actually want it to be transparent. This is going to be a container to hold the event trigger. It's also going to hold the camera area controller script we'll create later. Importantly, make sure you select this to be a raycast target. That needs to be selected so that when we press a button, it'll actually know that it was clicked and it will respond accordingly. Now we're going to add the 3 different components. Go ahead and right click on your cam_storage room and create a new UI image. Rename it cam_BG for background. Go ahead and duplicate the cam_BG by pressing Ctrl D. This is now going to be our frame, so rename it to cam_frame. Finally, we're going to add our text. Right click, go to UI and add a Text Mesh Pro text. Call this one Cam Label. I changed the text inside to actually say Cam 1A. It's very possible you did not have Text Mesh Pro already loaded as a package. If a warning box pops up that says, do you want to add this? Just click yes. Go ahead and take a few minutes and resize everything. Make the text smaller so it fits within the box, and mess with the frame if you want a different border. Here I've sped up the process, but I started by resizing the overall parent camera object to something that I liked. I then used the anchor tool within the rect transform of each child. This allowed me to expand or contract them to fit inside of the parent object. I then selected the text, adjusted the font size, and centered it. Finally, I adjusted the background color to be a lighter gray so it would stand out from the map, and then I assigned my frame sprite to the frame image. Now don't go duplicating this object yet to create all the other cameras in your scene. We're going to add some scripts to this first and wire everything up. Then you can start duplicating them and adding as many as you want. Now we're going to create a script that's going to handle not only blinking, but also store some important references for different images and things that we're going to need later on. Right-click in your project and create a new script. Call this Camera Area Controller. You can go to my website to find the entire script to copy and paste, or you can type it yourself by watching here. At the top, we have a texture, and that's the room background sprite. This is going to be whatever texture that camera is going to be associated with. And what I mean is the background image that is going to show. So for our storage closet, our storage room, that's going to be an image of the storage closet. Next up is our camera UI background. This is the background we created in the last video. This is a reference to it so that we can change the background on the screen. Next up are 2 colors. The first is our normal color and our blinking color. I set these by default to black and white. you can change them to be whatever you want to. This is going to cause our button to flash whenever we click it. Next up is our blink interval. This is how long to wait before flashing between the two different states. And then finally is our coroutine that will actually control this blinking on and off. Our first function is called start blinking. It's going to stop any blinking if there was any going on, and then it's going to start the blinking loop coroutine. Stop blinking checks whether or not a coroutine is actually there, replaces it with null if it is, and then goes ahead and sets the color of that button to be normal again. Finally, there's blink loop. This is going to operate in the background using a while statement. This is going to constantly toggle the state of the camera to either be the blinking color or the normal color. And then it's going to wait until that blink interval passes before swapping again to the other one. Let's set up the camera manager, which is going to control two different things. It's going to control which room is currently being viewed, that is what image is displayed on that background UI element, and it's going to control which camera is blinking on our UI menu. Go ahead and create a camera manager game object and create a new camera manager script and attach it to it. Let's take a few moments to go through this script as well. It holds one important reference at the top, and that's a raw image reference to the background. That was the background we were working with in the last video. Then we have a private element that holds the material. Remember, it's our custom material that actually holds the shader that allows all those cool effects to happen. So we're going to be changing the texture in the shader, not the texture on the image itself. Finally is a reference to the last camera area controller. This is so we can turn off the blinking on the last object we had selected. In the start function, we just find the material, grab a hold of it, and keep it as a reference so we can manipulate it later on. Within void select camera, we take in a camera area controller reference. We go ahead and change the texture of our background image to be whatever was stored in that camera area controller. We then tell that particular button to stop blinking, and then we start blinking the new button. And we store that new button away so that the next time we press on something, that will then be turned off and the new one can be turned on. Now it's time for us to hook up all the events. Right now you only have the cam_storage closet to work with. Go ahead and select it so you see everything in the inspector. Go ahead and add an event trigger to this object. Drag and drop the camera manager as a reference to that object. Make sure you select the camera manager's select camera function, and then drag and drop the cam storage closet reference in there. This is going to pass all the information we need into the camera manager to control the blinking and swap the background. You should already have your camera area controller, but make sure you fill in all the references. Remember that the room background sprite is different for every single camera you set up. Here, I've drag and dropped the closet room. The camera UI background is a reference to that cam BG, the background image we created in this UI element. That's going to be the part that changes color from the normal color you selected to the blinking color you selected. Now's the time when you can control and duplicate that camera and lay them out all across your map. I'm only going to be making 3 today. Use a transform tool to move them around on top of your map. I've created a bathroom and a repair center. Under each of those cameras, make sure you drag and drop the correct background that you want to use. For my bathroom, I used this image from the restroom I had made in my previous Five Nights at Freddy's 3D game. And then for the repair center, I took a little bit of time and made this moody scene where we have my version of Foxy on display. Click on the camera manager and make sure you add the last reference. That's the background reference. You need to drag and drop the background image you were using, the raw image itself that we set up in the previous video, into that reference. Now let's go ahead and hit play again and test this out. And now with the game running, I can move my mouse down, I can see all the different UI camera elements, I can click on any of them and move between the different locations. Now one thing we haven't added yet, it'll be in the future, is that Five Nights at Freddy's defaults to that first camera 1A. We can add that functionality later. In a future video, we'll make it so that the room will actually change back to that office space you started with. If you're the creator tier supporter on Patreon, you'll have access to this entire package and all of these elements, including the entire scene. In the next video, we're going to add the most iconic element of this game, the jump scares. Make sure between now and when the next video is released, you spend some time drawing what your animatronics are going to be and getting them into the computer. I'll be asking my sons to give me some of their drawings to use, and I'll also be using some of the 3D renders from my previous FNAF game. So your challenge is to go ahead and expand this map and add as many different cameras and locations as you want. If you have enjoyed this series so far, please hit the like button, leave a comment, and consider subscribing. Thank you all for watching. So long and goodbye.